Hi, it's Mr. Benson here with a quick video on plotting linear graphs. So this is for exercise 7a of the linear graphs chapter. Now you've already done most of this stuff if you've done Are You Ready? So there's not a lot here that's actually new, and this video is quite short. Okay, so parts of a linear equation. Now when you're plotting equations, they will be in what we call the standard form, and this is often described as y equals mx plus c. So there are the three parts of the equation. So obviously the y value is y, the x value is x. M is what we call the gradient. Now it's the number that describes the slope of the line. We'll look at that in a little bit more detail later on. C, which in this case this equation, sorry, skipped a page. C in this equation is the number 3, and that is called the y-intercept. It tells you where the line cuts the y-axis. So those two terms, gradient and y-intercept, we will use a lot of. And look, it's really important that you do get familiar with these, because linear equations and linear graphs is a really important part of maths all the way through. So the sooner you are familiar with them, the better. Okay, so gradient, what do we mean by that? Now I've got an equation here for y equals 2x minus 1. Now I haven't actually labelled anything, which is a bit bad of me, but I'll quickly do that again, and that will help remind you where things need to go. So the y-axis is always vertical, the x-axis is always the horizontal one. 0 in the middle is the origin, so it's where x and y are both 0. Now I'm just going to quickly number these. Now the scale we're using here is just 1 to 1, so 1 square is one number, and positive y values go up, positive x values go across to the right. Okay, so now I've got my Cartesian plane. Now the equation for y equals 2x minus 1. Now firstly we'll think about the gradient. Now the gradient is the amount moved up divided by the amount moved across. Now in this case our gradient is the number 2. Now another way of describing the gradient is that it is the rise over the run. So rise is how much we're going up, and run is how much we're going across. Now always work from left to right, so that will always make your run a positive number, and that you'll see later makes things a little easier. You can still get the right answer if you do it the other way, but it's just confusing and you're more likely to make mistakes. So in this case, I'm just going to pick a point on the graph to start from. Any point's fine, so I'm going to pick this one here. Now if I go across 1, now actually one thing I'd like to quickly mention here as well is, remember that if you've got y equals 2x plus minus 1, you could rewrite the number 2 as a fraction, because remember that anything divided by 1 is itself. So we could say it's y equals 2 over 1x minus 1. Now the reason this is quite good is, remember that gradient is rise over run. Well, if you write the gradient as a fraction, then you've got the rise in your numerator and your run in your denominator. So I'm going to go across 1. That was my denominator, so I'm going to end up at 1 on the x-axis. Then I'm going to count how far I have to move up to get to the onto the line, and I had to go up 2. So my rise in this case was 2, and my run was 1, giving me a value of 2, which is the value from my equation. So you can see that the gradient is telling you basically what the slope of the line is. So if you go across 1 and up 2, it will look like this. If our gradient was a negative number, it would tell us that when we went across 1, we would go down, and so our line would slope in the opposite direction. We'll look at that more a little bit later. Now one other part of the equation that I want to remind you of is the y-intercept. Now in this case the y-intercept is minus 1. If you have a look at this graph, now this was the point I started at, that was just a coincidence. You can see that where we intersect with the y-axis is at -1. So this is C. Our y-intercept is -1. Now, a quick example of plotting. When we're plotting, we use a table of values. So we've got our domain of x values here, and we're just going to fill in the y values here. So I've got y equals x plus 2, which is a nice simple equation. And all I've got to do is put those values in. So when x is -3, y will be -3 plus 2, which will just be -1. When it's -2, well, -2 plus 2 is 0. -1 plus 2 is +1. Now you might have realized by now that we've got a change of 1 at each step. So I can stop doing calculations now, and I can actually just add 1 to each of my answers. Worthwhile checking that I'm doing the right thing though. So for y equals 3 plus 2, well, 3 plus 2 is 5, so I'm on the right track. Then all we have to do after that is we just need to plot them on the axes. So here is my Cartesian plane. Now I'm going to label it up properly. This is y, this is x. I've got my origin in the middle here. Now when I have a look at my points, I'm going to run out of room again, but I'm not too worried about that. No, actually, in this case I won't, because I'm going to change my scale slightly. I'll show you how you can do that. And it doesn't actually matter if your x and y axes have different scales, as long as they are both consistent with each other. I'll show you what I mean by that. So firstly, our x values, we go -3, -2, -1, 0, 1, 2, 3, so they fit on nicely. Now when I look at my y values, I can see my maximum y value is 5. So if I use the same scale, I would be off the top of the screen somewhere, so that's not too useful. What I'm going to do is I'm going to make a different scale on the y-axis. So each of these squares is going to be 2. Now that's fine. I'm being consistent so that it's always a difference of 2 no matter where I am on the y-axis. It doesn't matter that it's a different scale on the x-axis. That's just something to be conscious of, because visibly the graphs might look unusual, but they are still correct. Now all I've got to do is start filling in my points, so for each xy pair. So when x is -3, y is -1. Now in this case, -1 isn't on the point, isn't on the crossing of these two lines here. It's going to be at that halfway mark there. It's a bit hard to see actually because of the 3, but anyway. Moving back, -2 is at 0, -1 is at 1. 0 is at 2. 1 is at 1.5. Sorry, 1 is at 3, halfway up on the scale, I mean. 2 is at 4, and 3 is at 5. Oh, and one of my points just disappeared. That was odd. Right, there we go. And what you can see is that the 7 points that I've drawn form a nice straight line. Now this is another really important idea that we're going to come to later, and you can see why plotting is a little bit of a silly idea. All I really need to do when I'm drawing a linear graph is draw 2 of the points, because once I've drawn 2 points, if I draw a line through those points, it will actually cross over where any other point on that line would be. So plotting is a little bit redundant in that respect. Okay, that's all for plotting graphs. You should be right now to attempt the 7A exercises.